All right, so this meetup today is for the Lightning Network feature of the Bitcoin network. I've been doing a couple of presentations for this meetup, and in talking with the leaders of this group, we realized this would be a good one to give now, since it is an up-and-coming feature of Bitcoin, and so we wanted to take a moment to do a deeper dive into this one. A little more about myself. I'm Brooks Boyd. Both my day job and my night job are web development, which has brought me to Bitcoin back in 2012, and I've done development on the Bitcoin core client, and back in the day some of the altcoins off of that one, and more recently into Solidity smart contract development for Ethereum, and all other sorts of dApps for those. The Madison blockchain Slack, you can find me on Midnight Lightning there, as well as Midnight Lightning on GitHub and many other online places. Or an email address there if you want to get in touch with me that way. And so to introduce this feature, I have to go back to a little bit to the presentation I gave last was on Bitcoin forks in general. And throughout the summer, we've actually had a lot of information and buzz and discussion about Bitcoin forks because we had a lot of flurry of activity about it. And in order to answer the question of what is the Lightning Network, we do need to do a little bit of the history into that one to give some context. This slide was in my previous presentation as well, just about forks, to give that bit of a background that over the last year, the Bitcoin community has been discussing the concept of how to scale. That the network has been becoming more popular, and as such, more people are using it, and the question is, how do you fit more into it? And there's many ways that this can be done, and that's led to a fracturing of the community as they approached a couple of different ways. This was the slide that I gave of where Bitcoin was at the end of the summer. When I gave my presentation, we were about here. The idea that back in August, some of these hard forks of Bitcoin started splitting off with different ideas of how to solve this scaling problem. For this presentation for today, we're following this blue one here. Mainly for this change. This change here was the segregated witness activation that happened back in August. This fork, which we talked about a lot last meetup, ended up not happening at all. So we're just on the blue. That orange one doesn't exist presently for that one. The main difference between the blue and the green for this one in terms of the communities that have centered around them or gathered around them is the blue line is the main Bitcoin line, sometimes also referred to as core, the core Bitcoin one, which is doing more for scaling on-chain. The idea of using a few features, developing them completely, fitting them together into a more complete picture, the sort of slow and steady wins the race sort of approach. The green line is the on-chain scaling, the just double the capacity, everything can fit on the blockchain, use the blockchain for all these things as opposed to developing new pieces of it. So that's kind of the psychological switch between the two. And so with the blue line idea, the core idea, the Bitcoin idea of off-chain scaling, of add these new features to it, lots of new features have started to come into development since this summer. There's this whole cloud of ideas. And with this sort of a scaling approach, the idea is none of these is a silver bullet that's going to solve the problem entirely. But each one gets closer to it, adds more capacity, adds more ideas. And so the idea of how do you fit more onto the blockchain idea. Segregated witness was activated earlier in the summer, and now the one we're talking about today is the Lightning Network, or more technically referred to the bi-directional payment channels network and what they represent. These other ones around here, which you may have heard, Schnorr signatures, Merkleized abstract syntax trees, or masked zero knowledge proofs, which are fun to say as CK snarks. The graphene, there's also bulletproofs and a couple of other things that are coming from different altcoins or different other cryptocurrencies that are all being discussed in terms of optimizing this. The main difference of all these ones in gray on the bottom are all network layer and sort of protocol layer that you as a user don't need to interact with for the most part. These two that are highlighted, they require some behavioral changes for you, the user. Which is why we're calling it out here. And that's the kind of approach that I'm going to be taking to this presentation. Even though I'm a developer and I've gained a lot of my knowledge from looking at the code itself, the way I'm going to be couching this is to you as users of what's this going to look like to me as a user. And we can get into more of the technical pieces if there's interest in those as well. But so it's the same way that, if you take it back to the idea of the original invention of the automobile, The first automobiles, you learned how to drive them, and it may have been, on the country back roads, and you just had to learn steering and brakes and gas and all that. But as more people started to drive, there were new concepts added, like expressways, traffic signals, street signs. You suddenly had to learn more. You need to learn how to merge onto an expressway. You need to learn, what does it mean with a blinking red light instead of a solid red light at a stoplight, all these additional things. And so that's what we're layering on with this sort of a scaling idea. It's now, the Lightning Network is something in addition to Bitcoin. So assuming that you all have some experience with Bitcoin and those transactions, that's all still relevant. You can still do that, but it'd be the same as like driving your car on a country road. You're going to be off in the distance a bit. The Lightning Network is the idea of now we're interacting with a lot more people. We need a few more reflexes, we need a few more tools to actually do that. So what does it look like? As I said, the technical piece of it, a bi-directional payment channel is the core of it. And that as a technical concept is actually being looked at on a couple of different cryptocurrencies. But the idea of just what that looks like from a technical perspective is that it is a protocol. It's a way for two nodes in a peer-to-peer network to talk to each other. And so it's like HTTP in that you have multiple web browsers that all speak HTTP. You can have multiple clients that'll all speak this Lightning protocol, or this bidirectional payment channel protocol. And the basic idea is two users throw some money together into a pot, which is termed a channel. From a technical side, there is a script hash. Bitcoin transactions have various opcodes that there are actually some smart things you can write with Bitcoin transactions. Historically, most of them have been a very simple pay X to address A, sort of a command. These scripts are getting more complex as they're being developed. But then the idea is once you have this pot of money where two people have thrown money together, the ratio of who contributed what is recorded as the state of the channel. If I threw in $1 and you threw in $2, keeping track of who has which piece of it. If we wanted to make a purchase or we wanted to adjust who owns what, some of the funds that, in the example of like Alice and Bob putting money together, some of what Alice threw in could be reallocated to Bob. And then when the two parties are done transacting, they can close it out, and whatever ratio they're supposed to get, it gets split back out again. That's the basic technical piece done in words. So let's take a look at graphics for those of you who might appreciate it that way. So taking the example of Alice is a customer who likes to go to Bob's Bakery. And so Alice, acting as a consumer, knows that she's wanting to do most things where she's going to pay Bob. Bob's money is going to flow that way. Even though this is a bi-directional payment channel, which we'll get to. The intent when Alice goes to Bob and said, hey, I'd like to start a payment channel with you, the intent is I'm going to be giving you money eventually because I'm the consumer of this. So Alice throws in 2 millibits and Bob throws in 1. What we end up with is a pot of money, which is 3, plus 1, and we keep track of the state. Alice threw in 2, Bob threw in 1. And so then if Alice wants to buy a lovely croissant from Bob, we're going to value that because it's a very, very great croissant. It's 3/4 of a millibit. All that they need to do is agree to the new split. This is still 3 in the middle. We haven't actually changed how much money is in this pot. Just Alice and Bob together agree. Bob's 1 has gone up to 175, and Alice's has gone down to 125. Also, Alice decides, oh, Bob's offering a new thing, a new very fancy coffee. So she'll add, okay, another 1/2 millibit. So they adjust again. So now the current state is it's still 3, but Bob owns 2 1/4 of it, and Alice only owns 3/4 of it. So she enjoys her meal. However, that very expensive coffee is also very hot, and she burns herself on it, as we all know that always happens with very expensive coffees. And she threatens to sue, and of course all these things, and Bob wants to keep a nice customer, so he agrees to compensate her back for getting burned with her very expensive coffee, 1 millibit. And this is where the bi-directional piece happens here. Bob can just reallocate. He had 225, so he can drop that back to 125 to give her 1 millibit back, sort of it. So they renegotiate the state. After all of those, they decide they're done transacting for a while and they're going to go their separate ways. And so they agree to close this payment channel out. The last state was Alice at 175, so she gets 175 millibits back and Bob gets 125. That's the basic idea of how a payment channel works. Which, looking at that one, you may have a couple of questions of the so what variety. That's really complex. Alice could have simply, she ended up just with a quarter of a millibit being spent. She could have simply said, here, done all of this verbally, and then sent Bob a quarter of a millibit and be done with it. The actual actions on the blockchain for a payment channel, it is one to open it, to throw the money into it, and then one to split it back out again. So yes, instead of doing 2 transactions on chain, she could have just done 1. So why the complexity? What benefits do we get out of this complexity if we're going to be doing that one? The thing to notice in there is, instead of looking at it as 2 transactions for 1 effective balance transfer, she did 3. There were actually 3 different things that happened in there, and there is metadata about these things did happen. If you were to do all 3 of those on chain, you would have all the benefits of blockchain technology, proven, verifiable, transmission of the funds. So instead of doing 3 on-chain transactions, she only had to do 2 in order to transmit it, and still this state data is kept in a verifiable way. And also why not just send the funds directly to the merchant? As I just mentioned, the idea of if there's a refund, well, then you need to make another transaction to send some of it back. Or even if it's a very large purchase, often merchants have the idea of like a down payment or a proof of your intent to do it. Well, then you're splitting a large payment into 2 different payments again. With a payment channel, it could just be for the one piece there. And of course, in my example, I gave the Alice and Bob are all on speaking terms and are agreeing with each other about current things. What happens if they disagree? And actually, the payment channels have that covered because that's where that script idea comes in. So this gets a little bit more on the technical side of what's actually happening in the Bitcoin network. So back to the idea of when Alice and Bob put their money together, part of that agreement, or part of that handshake of how they create that pot of money, ends up with Alice and Bob each holding a transaction. Alice's transaction says, send 1 millibit to Bob, which is his ratio, immediately, and send 2 millibits to Alice after a week has passed with no fraud proof. And Bob's is actually the reverse. Send 2 to Alice immediately and 1 to Bob only after some sort of a time delay. And that's actually a variable they can agree on how long that time delay is. So as part of the opening of it, these 2 transactions exist for the 2 users, but those are held privately. They don't actually mine those or transmit them to be mined into the blockchain. They're just held privately. So then we have this purchase again. Alice purchases a croissant. She updates the state of it. As part of that handshake of how Alice and Bob renegotiate that state, they each end up with a new transaction. Now Alice's, instead of saying send 1 to Bob immediately, it says send 1.5 to them. So that's how the state is actually updated in these 2 transactions that are held privately. Alice's red one becomes an orange one, which is with a new updated piece here. We're talking about the idea of what if they don't agree. So at this point, Alice bites into her croissant and finds a cockroach. She blows up at Bob, says he's ruined her life, and storms out and swears never to talk to Bob again. So where does this stand now? Their funds are still locked in the payment channel. So if Alice is true to her word and she doesn't want to talk to Bob ever again, she can simply transmit this transaction to the Bitcoin blockchain because it has everything that she needs to get her money back. The 175 goes to Bob immediately, and 125 is put into a holding pattern for her, and after the week has passed, it gets transmitted to her. The week has passed, it doesn't need Bob to actually do that one. If they're on speaking terms, Bob can actually trigger that one earlier. But even if he's not, that's how that can resolve, even with someone bowing out of the situation. Once you have this current state, that's your provable, trusted ability to get your funds back, even if the other party stops being responsive for that.
If Alice wanted her funds back, wouldn't she broadcast the first transaction and not the second one?
Oh, yes. If she was being very nefarious, she might say, well, hey, I really don't like Bob anymore, and I have this one that says Bob gets 175, but I have this one that says Bob only gets 1. So I'm going to transmit that one. Good transition, man. So she says, why would I give him 175 when I have a transaction that says he only gets 1? So she sends that one out. And indeed, Bob gets the 1 immediately, and 2 are now held for her for the week. And of course, the key there is with no fraud proof. So the piece here that can protect Bob, because Alice has now broken their contract. If she's transmitted something that she was actually supposed to throw away, those states were supposed to be lost to history. And the way this is managed, you can see I added one more little colored bit here to it. The colors here not only represent who owns the transaction, the red and yellow or red and blue for Alice and Bob, but it represents a secret that each of them created as part of that transaction. So when Alice created this one and this initial handshake with Bob, she made a secret key, the red key, that locked up this one. And then as part of settling this one, Bob had a blue key on his. As part of settling it, Bob told Alice what the blue key is, and Alice created a new key, orange, for her own secret. So the point is, Alice's secret red key got transmitted to Bob. He has that now because they did a state update. So, with that 1 week was what they agreed to for the fraud proof, all Bob has to do is make a transaction with that red key, and now the 2 millibits goes to him and not Alice. So for her breaking the rules, she forfeits everything she had in that channel. So there's the proof that you had in the trust in this piece of it. And also, even though Bob is the merchant and doesn't really probably going to be sending funds this way, the fact that he's throwing a millibit into the transaction, if this were flipped, if Bob was the bad party, if you were dealing with a merchant that you don't trust, you could ask them to throw in some collateral. Because then if they misbehave, that's their portion that gets given to you as a reward for them misbehaving, piece of it. So all that mechanism in the middle there is how the payment channel logic itself, without being an actual person in the middle acting as an escrow, that the fancy math of cryptography can actually work to give you trust for either side without having to actually trust the other party to do what they're supposed to. So up to this point, I've been talking about two people and a bi-directional payment channel. So to take that one step further to what is the Lightning Network, a Lightning Network is the idea that you can have many of these. A payment channel is two people and two people only. However, you can open multiple. I can open one with one individual person and one with someone else. And if everyone starts doing that, opens one or two or three, you suddenly have this web of interconnected nodes. It actually starts looking a lot like our internet backbone of how the various networks connect to each other throughout across it. The key piece of the payments channel to make it into a network is a payment can pass over someone in the middle, that you can route funds to someone that you are not directly connected to by using ones that you are directly connected to, which is a big mouthful to say, and I have a visualization for that. So let's make this into a network. And so for the first example, we're going to use an example from like real life. We still have Alice and Bob. And so again, Alice has been a customer of Bob, and we'll say like she has a frequent customer card there that she likes making purchases of Bob. She gets extra points for that. Carol, and we've now got Dave's Donuts here. I will say, Carol has a gift card for Dave's Donuts, so she's willing to pay for things at Dave's Donuts. And Alice and Carol are friends who often go out together. And one day, Alice and Carol decide to go to Bob's Bakery. And of course, Alice, who has the frequent customer card there, says, "Oh, I'll pay." So Carol, who wants to purchase something for $3, the money actually comes from Alice. Bob gets the $3, but now Carol owes Alice $3. It's kind of, as a friend, it's the only for the next time. And indeed, the next time Alice and Carol go out, they go to Dave's Donuts. And Alice wants to buy something for $5. Because Carol's got the gift card there, she says, "I'll buy, and use up my credit with you." This the agreement between friends. So the $5 for Dave actually comes from Carol. Of course, the way this math works, she already owed $3, so therefore now it's flipped the other way that Alice owes Carol too. And we've all done this, amongst friends, and whether or not you actually keep the balance in the middle, sort of a thing. If it gets too lopsided one way, you might start questioning one of your friends. On that, we don't usually keep the actual ledger of those. But this same idea of Alice did not have a relationship with Dave, but she was able to use her relationship with Carol to get a payment to Dave. So let's redo this as payment channels. So we're back to Alice and Bob have that same channel they had previously. 3 total millibits, 2 from Alice, 1 from Bob. And now Carol has one with Dave of the exact same way, 2 and 1 for that way. But now Alice and Carol, for settling up just their friendly purchases amongst them, each threw 1 millibit into a channel between them. So now, if Carol wants that lovely croissant from Bob, that 3/4 of a millibit, over here we can see Bob's balance went from 1 to 175. And Carol's here went from 1 to 0.2. So where did the 75 actually go here? The channel between Alice and Carol, the 0.75 went to Alice, but then 0.75 of Alice's over here went to Bob. So Alice still has 1 plus 2 is 3, 175 plus 125 is still 3. She still has 3 millibits owed to her. It's just that it's now owed to her from a slightly different channel. Same thing if we wanted to go the other way. If Alice wants to buy a dozen donuts from Dave, she can send 2 millibits back the other way, using more of that payment in the middle there. Dave ends up going from 1 to 2.25, which is what the purchase was for, and it's just balanced by the fact that Alice and Carol's payment channel between them does that. That sort of makes sense? It's a lot of little fractions and numbers. So that's the kind of way to visualize that idea of what we already do kind of when we're out with friends. And this works as a payment network. And it may end up being shaped this way of users in the middle connecting businesses on the outside if users start adopting Lightning Network before businesses do. But it also means that because your funds are get locked up into a payment channel until it closes, this one in the middle here is a pretty weak transaction. Alice almost depleted it by buying a dozen donuts. She now doesn't have enough credit with Carol to actually buy another dozen. They would need to close that channel, reopen it, and refigure something out before that would go across. So instead of relying on users to fulfill that middle bit, what's most likely to happen, or what people are predicting, is to flip this inside out. That the users are on the outside and the companies are on the inside. Such that Carol, who does most of her business with Dave's Donuts, makes one channel with Dave. Dave is a business. That entity will have more funds or liquid assets than an individual, most likely. And so they can make a fatter pipe, likely between Dave and Bob. Or in this case, they're both bakeries. You can say like they have a relationship where if they have unused flour, they might transact between themselves, sort of a thing, or the supply chain piece there. So with this one, we have the same idea of the funds can flow deeper into the network, but now Alice and Carol aren't depleting their own funds except for their own transactions. Carol's relationship with Dave was not affected by Alice's relationship with Dave, piece of it.
Yeah, are there not economic incentives allowed for in Lightning Network as well, where you can extract a toll essentially
Yes.
for relaying a payment?
Yep, yes, there is that idea that if you're the middleman hopping across something, you can charge a fee for it. And right now there's a bunch of, or the clients know how to negotiate and find the cheapest route through the network. So yeah, there'd be financial incentive both to, if you are highly connected, that you can use that as a means of profit. That if you wanted to start a business that was mainly about, here, I'm gonna make dozens of connections and you can use my connections by charging a small fee. That's how I make my profit, piece of it. That is a potential business opportunity that's being introduced by this.
So Brooks, this is all, like you said at the beginning, to reduce the number of on-chain transactions.
Right.
Those are just taking advantage of open channels, money that's sort of there to be moved around to
Right.
reduce
Because
the
this
end-to-end
idea,
transactions. Okay.
yep, if we get towards this shape of a network where the user's on the outside and have like one main connection inbound, that evolves into the idea of, right now I kept the examples the same throughout all this, of Carol and Alice are only throwing in 2 millibits, the amount that they would normally transact with the one vendor they're connected to. If we get towards this sort of situation, the idea is the users would be putting in the amount of funds that would be like a credit or like a checking account, your slush fund of how much money are you going to spend in a month. This is your one on-ramp into the entire network. You can find all the people within it. If you have your hot wallet, your slush fund of how much are you expecting to spend in a month, you make one transaction to open one payment channel with that amount, and then for the rest of the month, you deplete that one, end of the month you close it out, open a new one to do that one, or even longer period if you want it. If you're actually doing things that might earn you money back, you might not deplete your channel and can keep it open longer, and then you're doing as many transactions as you need without needing to actually close out the channel. That make sense?
Mm-hmm.
And so this one, so to extrapolate that simple example into just the more visual of, yeah, this sort of a topology is what they're sort of expecting the Lightning Network to end up with. That you have a few nodes or individuals that have just one connection in, and some that have a few, and then a few core in the middle that have many, many connections. And the idea that any node on this graph could pay any other node on this graph. That if this one user was Alice and Carol was way over there, that they could actually route it through a multi-hop connection to get there. And if one of these connections was depleted and couldn't be used, it could be routed around them to get to them also. So the more connections the network has, the more robust it is, even without individual users or smaller nodes being disadvantaged by only having one connection in. We may get a situation of, like this node over here clearly has many connections, and many of them are just single ones. This sort of a situation may be like a credit card company or a subscriber service where a lot of people, that's their primary payment. But also that was their gateway onto this network. If this node decides to start charging fees, yeah, all of these users will start paying the fee. And maybe they don't mind, it's a good service, they like to support it. But if they don't want to pay the fee, if it's just getting too exorbitant, all they need to do is open another connection to someone else and get a different connection into the network. That makes sense?
So will the network be able to handle things where like a bad actor closes a node to reroute something like that?
Which, it's the same idea of closing a node, or if someone, closes out a channel. It'd be the same idea of the way that the current internet backbone idea reacts to devices going online and offline. You find a route through to find, when you're looking up the DNS entry to this particular IP address, perhaps it's one route one way, then if there's an outage, it routes around it. And the protocol itself is defining how that routing sorts of happens, the negotiating that happens for those.
And are Alice and Carol still creating bi-directional payment channel directly to each other that's negotiated through the Lightning Network, or is their connection simply to the network?
It's at their option. Alice and Carol could, if they wanted to, if they know that as friends they're doing a lot of transactions together, sure, they could do one, and therefore they're guaranteed to not pay any fees to any middleman. But if they're only transacting with each other infrequently, they might be willing to pay a fee once a month, for whoever's the hop in the middle between them.
Sorry, I guess my question more is, is their connection just to the Lightning Network, and then do they later say, I want to transact with you, and since we're both on the same Lightning Network, since we're both on PayPal,
sure,
right?
So that idea of, yes, so the network part of the Lightning Network is a peer-to-peer network.
Right.
And so each of these nodes has to be running a piece of software that knows how to talk the Lightning protocol. But yes, there needs to be a discovery. After you started joining the network, then you need to actually intentionally make a connection to the other one. Which is a little bit different than like most peer-to-peer networks, because most of the peer-to-peer networks, it's a free connection to another node. This one, you're actually putting money on the line. You actually need to have a negotiation of, well, I'm putting 3 in, will you put 3 in? Oh, no, you don't want to? Okay, will you put 2 in? Sort of a thing, to actually establish those links.
So, just real quick, when you're talking about negotiation on the peer-to-peer side of things, I get the flexibility of being able to establish those rules. You have the ability to have like a reusable contract, so when you're making a payment to another entity who's on the network, you're not negotiating the rules of the transaction every time, but you're recycling an existing set of rules.
Yes, so all of these, so like here are these words that I used for these ones. Yes, the idea is, like, these are the equivalent of like an HTTP request. You as a user won't be writing these. This will be like your wallet software, your equivalent of your browser.
But that seems to be negotiable on a transaction by transaction basis, as opposed to...
In the same way that every HTTP request you make rewrites rewrites a message that adheres to the protocol. This one, they've created some standard scripts, which have some variables like how long is the fraud protection time in there. But each wallet now is going to stamp out that transaction, or that template, as it were, each time. Does that make sense?
Yeah.
Okay. Maybe.
No, it's fine. It's just, so I come from Visa, so it's like, that's of all the failures that Visa has in their claim, some of the ones that they have is that standard when you're talking about going on a global scale. So, I mean, I see a lot of potential here, but it's knocking back the friction that's critical.
Sure.
And so being able to have, that flexibility is great, but having a standard template that people can just tap and go is also. Okay.
Okay. So one of the other counter examples to it is people say, well, this is a lot like, opening a tab at a bar is how this is you're putting the money up front. And one of the counters to people saying, I don't want to use these ideas is you're putting your money up front and saying, well, I don't do that for most of my transactions. And that's true. Here in America, unless it's like a bar or putting it down collateral or putting down a down payment, that's not the way we do transactions. We mostly get the goods on a trust basis to pay for them later. So for merchants, there may not be as many one-to-one options for making use of a couple of these features. Most of the benefits are going to be the fact that the network allows you to make one inlet and transact with many merchants. But there are many opportunities for one merchant transacting with one person to take advantage of this fact that all these state updates to a channel are much, much cheaper and tending to be pretty much free to actually do those. So the idea of, with a restaurant, when you order the appetizer, when you order the dinner, when you order the dessert, could be separate state updates that instead of paying at the end of the meal, if you actually put the money down at the beginning and then slowly filtered off of, oh wait, I didn't decide to do an appetizer, I'm actually going to keep that part back. At the end of the meal, you actually give the money over. That actually gives the verifiability to the restaurant. The restaurant isn't needing to trust that you're able to pay at the end of the meal. And of course, that example, I know from my childhood, I had the experience where we were eating at a restaurant and halfway through the meal, we got one of the cooks come out of the kitchen, get the restaurant's attention and announce they had a fire in the kitchen that they couldn't contain. So for everyone's safety, please get out, but please come back and pay your bill if you can. It's like, they had to very much trust that people would come back and actually pay for it. With this sort of a situation, if there was actually a state change, when you order the appetizer, when the entree hits your table, the restaurant, if there was a fire and everyone had to get out, could still get their funds back from everyone who was there. So there's benefits for the merchant there. Same with like grocery shopping or any other brick and mortar. When you take something off the shelf and put it into your cart, it's not yours yet, but there's sort of a trust that you are going to pay for it. Or in a grocery store, you could open it and start eating it. You might get some odd looks, but on the faith that you would actually be able to pay for it. So there's again a trust there. Internet cafe, you may pay by the minute or pay by the 5 minute. With this sort of a state updates, you could pay as fast as the computers are able to keep up with state updates, pay every 5 seconds. Sort of a thing, however many fractions of a cent every 5 seconds that you want to pay for. And the idea that anything that you currently pay with a monthly subscription fee, your Netflix fee, they charge you monthly, but the reason for that is they could charge you, a 30th of that every day. Why do they not do that? Because that would be really annoying. You have to pay them 30 transactions every day. But the part of that's the trust is if you want to cancel your Netflix service, either you've used a fraction of your month or they need to refund you for the fraction of the month that you didn't pay. And it's either they're trusting that you'll pay for the fraction you did use, or depending on how your billing is, that you're trusting that they might refund you for the fraction of the month you didn't use. With this sort of a setup, if they were actually updating the state every day, you could part company with them and get all of your fractional piece back there. So there's a lot of opportunities for that sort of idea of slicing up purchases into smaller pieces. That isn't what merchants are doing right now, but with this sort of technology they could, and it might be a benefit for them. All right, so that's the concept, and that's what's been proposed. And the question is, where are we now with this one? The current state of this feature, as I mentioned, it's a protocol, and so many applications can implement it. And right now there's a couple of leaders, there's a couple other implementations, but I grabbed a couple of the big names right now. Lit and C Lightning from MIT and Elements Project are both command line utilities, so you need a bit more technical experience to work with those. The two big GUI projects that have gotten some traction right now, Lightning Labs has a desktop app as well as a command line client, and Async, I believe I'm pronouncing that correctly, has their Eclair project, which is both a desktop app and an Android app, is where they're at right now. However, all of these are still operating on the Bitcoin Testnet network. They have gotten a lot of the interoperability working. That first premise of it's a protocol, that means the Eclair wallet should be able to talk to the Lightning Labs client if they're talking the same language. They've gotten past a lot of those hurdles of now most all of them are talking to each other, and now it's a matter of final polish and user interfaces and user experiences to get these sort of configurations in there. On the testnet, there's a couple of applications that have popped up to let you try using it. The async company has created StarBlocks as a coffee store. It is fake, you don't actually need coffee, but it's an idea of how you could expect a merchant transaction to happen for that. And y'all's has been created as an idea of how a paywall service could be implemented. For each of the articles, you need to spend 1 cent to get access to the article, which is cheap enough, but it's also a testnet Bitcoin, so it's actually worthless piece of it that way for those on there. And there's been, most recently, these were actually just like last week, a couple of companies that are starting to experiment with Livenet actual payments for actual real services. With TorGuard as a VPN and BitRefill as a phone plan recharging one, do accept live Bitcoin network or Bitcoin blockchain Livenet Lightning transactions. They've actually modified the code because most all of these, you can download these yourself, but if you download them, they're hard coded to be on the testnet. In order to be on the live network, you actually need to modify the code and recompile it yourself. Daunting task for most users at this point, for good reason. They're like pre-alpha on that one. But if you are willing to risk that and want to try it, you actually can buy a VPN service through Lightning Network directly to TorGuard, or refill your phone plan that way if you don't mind risking losing your funds in the technical glitch. And so here is the actual, this is the testnet network that exists right now. So parallel to my example one of, this is what we think it'll look like, this is what it actually looks like on the testnet right now. And so there are plenty of people trying it and getting up on it. All the blue nodes are just anonymous nodes. The colored ones are actually ones that represent, that actually have given themselves a name. And so a few of them, like you can see, are representing that sort of idea where there's one main on-ramp for several people, as well as ones that want to be just hyper-connected in the dense center of it, connected to other highly connected nodes, as opposed to being connected to individually connected nodes for that one. Yes?
So if both the parties in the, let's say, simple transaction, bi-directional connection, if both lose their records for their transactions, it's gone, right? I mean, it's not, nothing's recorded on blockchain, so no.
Right. So that's one of the downsides of a Lightning Network is with the main Bitcoin network, any transaction that's put forth into the memory pool to be added to the actual blockchain, all the nodes verify its authenticity and keep a copy of it. When you're on a payment channel, those transactions that are privately held are only held on your devices. You don't have the rest of the network to verify it for you. You yourself can verify them, but it's then also up to your own operational security to keep those transactions safe while they are in your private state, not on the blockchain state.
But when the time lock verify expires, then the funds would redistribute back to the original.
If you had already broadcasted. That was the, so here, the one here that I shaded, that Alice sent it to the main blockchain.
Okay.
If, solar flare,
Neither party.
solar flare happened, it was wiped out before she did that.
Yeah.
Yes, that could wipe out both of those if for some reason both Bob and Alice had data hard drive failures and lost both the purple and the yellow on the orange here. Yes, that would be locked, I believe.
But you can't start transacting until you broadcast one.
Right. The initial throwing together into this one was an on-chain transaction. But then if you lose the key to that one, same as losing your private key to any other address. Same thing, yeah, if you lost your private key to your main one, it's locked forever. Piece of it. So you do have as opposed to that sort of idea where if you lose your private key, you yourself are screwed. If one of these parties loses their half of it, as long as Alice is still on speaking terms with Bob, she could have Bob publish his purple one if she's lost her orange one. Yeah.
When these settle on chain, or each state changes that timestamp in the chain?
The state changes are not timestamped because they're not broadcast to the chain yet. They will be timestamped the moment they're actually broadcast.
So when it settles on chain, so let's say like I open a channel and make a payment to you right now, but it settles a week later. Do I have that timestamp of it was today and I did it to you today when it actually does settle, or go back to the chain later on?
Right. The internal metadata here of the fact that Alice made 3 individual things before closing it out is verifiable by Alice and Bob, but it is not verifiable by people with just access to the blockchain. People with just access to the blockchain would see only the in and the out for this one. So that's part of the benefit and how this actually becomes a space savings. Because it becomes the, do we really need a global, permanent, immutable ledger of every time you order coffee? Probably not. But if we're trying to do money laundering and figure out, have you ever transacted with Bob? That would be good to have as a provable thing. And if we can see that, oh, you transacted with Bob, what was it? Either you or Bob could reveal this metadata in the middle. And so that's how we get a bunch of the space savings also for the blockchain scalability, move a lot of the unnecessary transactions into private ownership, and you can then choose, do I want it to be an on-chain one and pay a on-chain transaction fee, or am I fine with it being a more microtransaction, which doesn't need to be as publicly verifiable as an on-chain one, which is fine that I mostly want the lump sum to be the verifiable piece that I get. Yeah.
So if someone hack to like both Bob and Alice device, that means all the virtual transaction will lost. So now the transaction will be here.
And if someone had access to your hard drive, yes, they would get access to whatever you were holding privately, possibly. But that would be the same as if they hacked your hard drive and got access to your private key. So yes, someone who grabbed this transaction could broadcast it. The nice thing about this one is it doesn't matter who has it. If someone broadcasts it, this one is hard-coded to pay Alice and Bob. So this transaction does nothing for an attacker because they can't modify where it's going. The destination addresses are already set in it. Sid?
Yeah, so there's a lot of criticism against Lightning Network is that it forms like a hub and spoke model where it like centralizes, where like people with high liquidity will be able to sort of control payments in the network. Could you talk a little bit more like the trade-offs between centralization and decentralization within if you're a user's transacting on the Lightning Network?
Sure. Yeah, the question, if you couldn't hear from the back, was the idea of just the centralization, or how do we avoid, if someone becomes a gateway piece of it, and that comes back to this sort of idea here of, for all of these users here, if this is their initial setup, they're bound by whatever this node is trying to do. So you could say they have a centralized situation. If, say that was Coinbase, who is very much, growing, has a lot of new users, they've got a great user experience, so most people will just say, hey, sure, I'll use that, I'll connect to that one. However, if they start becoming toxic, if they start becoming a bad player, if they start charging fees or refusing to route properly, sort of a thing, the idea with this sort of a network is that it could be a hub and spoke that way, but it doesn't have to be. There's nothing dictating that. The same way that an internet network doesn't dictate who you have to connect to, or a peer-to-peer network. You can route around it. It takes user knowledge and awareness to be able to say, wait, I want to break away from this one, to be able to identify, hey, this is a bad actor, I want to intentionally go away from it. But the protocol itself doesn't stop that. That's just a user education problem.
So it seems like the Lightning compatible apps will have to make a lot of good decisions in the background.
So yeah, obviously this being a pre-alpha app right now, it's a question of, right now your browser doesn't show you every HTTP request. Yes, there's a developer console and you could go watch every single CSS and JavaScript and HTML request that it makes. Most of the time you don't need to. And so we're going to be getting to that right now. Yeah, it's going to be very low level to start with as they're building up these ideas.
It's kind of a continuation of that. How is this, or the system you decide how long to time lock different channels, because it seems like you'd want to keep things off the chain as long as possible. So
Sure.
We'll set years long.
Well, the only time piece variable that you got there is the fraud proof piece. For this one, that's only and so the variable of how long of a fraud proof do you want to stick on an individual one is pretty much how much do you trust the other party. Because the only thing that affects is once someone tries to close it, how long do I have as a user to verify everything's on the up and up? This channel could have remained open for years.
You keep updating the
You just keep updating the state. They could have made one transaction, now, and and Alice, goes into a coma and wakes up 3 years later, and then says, "Hey, I've actually still got a payment channel. I'm going to go buy a croissant now." Yeah, the channel will stay open with that state, presuming Bob didn't close it while she was in a coma for that one. So the timing between the state changes is not dependent on time. It's only dependent on the two parties negotiating of do you want to update the state and making that request. The only time variable is here, and you can choose that for every channel. If you're working with a merchant that you don't trust, yeah, you may want to set that to a month. If the merchant closed the channel, and you know that you're the outdoorsy type and you're not online all the time, and you might not notice, hey, they broadcast something. If your fraud proof is a month long, it means you only need to be online once a week to check and see, did they actually close the channel? Okay, verify, did they close it properly? If they didn't, show the fraud proof. So that variable there is more dependent on how often are you going to be online to check it, and the trust that you have in the other party. Yeah.
Does it take both parties to extend the fraud period? Like if you want to keep it
Yes.
open indefinitely, but you don't want to set an arbitrarily long time period?
I believe the fraud proof has to be the same on both sides piece of it, but that's just part of the protocol, and that could possibly change in the future. If Alice has proven that she's trustworthy and so she only has a fraud proof of a day, but Bob is untrusted yet, so he has one of a week or whatever. Possible. I don't think that's part of the definition of the protocol at this point. I think they're all symmetric.
How do you find the cheapest path through a big enough network without knowing all of the states of the payment channels?
That one, the broadcast request, that's part of the peer-to-peer network broadcasts. In the same way that most peer-to-peer networks have kind of like a peer discovery of can you give me a list of your peers? Who are you connected to? Who are you connected to? There's those sort of communication messages that can be sent amongst the nodes.
And the sender has to know all that information before it sends a transaction to someone on the other side?
Well, the sender over here says, well, I'm trying to get over to that peer. So it'll ask the one person, are you connected to that peer? No. Okay, well, tell me who you are connected to. I'm connected to him. All right, so I'm going to go contact him. Are you connected to that? Yeah.
Right, but then if you're trying to find the cheapest path, you need to know all possible routes.
Mm-hmm. And yeah, there's probably going to be lots of opportunity for optimization of that, and possible some companies that'll help facilitate finding the cheapest routes on that one. Yes, I'm sure there'll be many algorithms and figuring out of those.
But it's not solved yet.
I think that's not solved yet, as far as I know. Or does anyone know differently on that one? No one. Yeah. So opportunity for growth there. Yeah.
How does the end recipient prove that they're the proper destination for funds when there's a multi-hop?
Each node is identified by a public key. So it's the same idea that your Bitcoin address is your Bitcoin address because you have a public key. It's a different format than a Bitcoin address, which is your base 58 sort of a string. But actually, let me show you instead of just telling you. Because I did pull up StarBlocks here. So this is their live site here. And as I mentioned, Async has the Eclair wallet, which I've actually got on my Android here. Let's see if I can pull this one up here. So this is the idea. So I have the Eclair wallet gives most all the Lightning wallets currently are half standard Bitcoin wallet. So it gives me a standard Bitcoin testnet address, one that starts with a 2NM for the moment, which is how I loaded it. I loaded it with a Net Faucet, sending it just as a standard on-chain transaction to my wallet, which this thing is recognizing I've got 1 Bitcoin worth in the standard on-chain address. But then in creating some payment channels, I've actually created manually from my wallet 2 channels, one open to StarBlocks and one to the y'all's one. So I'm directly connected to those two. I'm connected directly to the StarBlocks one, not to y'all's. I'm connected to one other, the Bitcoin Testnet Faucet. I'll be able to show I'm not directly connected to y'all's, but I am directly connected to StarBlocks. And so with StarBlocks, if I say I'm going to want a blockachino for 100th of a millibit, this one, I don't need to define checkout, thank you, Mac. So this is the sort of thing that it looks like when a merchant actually creates the invoice here. This is a base 58 encoded string, which if I want to send and scan a payment request, that one, and that one, what it actually is when it's decoded is a phrase that starts with Lightning, and it gives down with the order number. StarBlocks doesn't give their node ID, but it actually filled in here the public key that I'm now trying to pay is a 035B5E, very long. It's basically the whole public key of StarBlocks. They filled in, it's 1 blockachino, it's 1/10 or 1/100th of a millibit. I hit pay over there, which is pending, and in theory, if my internet is up, it should not take 10 minutes to do an on-chain transaction. There we go, and it pays through that one. And both of them recognize that it was paid through that one. So yeah, that's the idea of transactions should be that fast for it. And indeed, that one did update. I paid 0.1511 was my fee on that one. Right now, Eclair doesn't like tell you what the fee is until afterwards and you see the actual transaction. So for the fee on this one, I actually paid an additional 11 on the end of it to actually get that transaction sent through. But here I can give one of these. Oh, we got some Let's see. Oh, problems with StarBlocks. I want to know what the problems are of this one. So this idea with it's now a paywall, you can get a preview of the articles. And I say, I want to continue reading this one. And so it generates one here, and in fact, this one actually shows here's our public ID, or public key, and so yeah, that's the address of who you're paying. I'm not directly connected to them, but if I just get the QR code so that the one on the whole QR code, the one on the left there is, they give a nice one of, the one on the left is the payment. If you aren't connected to anyone yet, they say, oh, we'll open a connection to you. I have already one there, so I only need that one. Yep, 1/1000th of a millibit. Put that one through, going through, pending. And they're recognized, and there it's through. And that article was not much longer than it was. That was a penny well spent on that one. This one, they also have the idea of, fine, sure, I'm going to give an emoji on that one. I'm going to react to that one, and it costs me another millibit to do that one. They've generated that transaction. Sure, I want to pay another penny in order to upvote that one. Even though that is a really short article, why would I be upvoting this? But that will scan in there. Pay another 1/100th of a, or 1,000th of a millibit. Get that one through there, pending. And that one. And there that went through, and it highlighted that, yep, I paid for the zap emoji on that one. That's the idea of the concept of how a merchant transaction would look on these. And of course, this is still just playing with testnet Bitcoins, but that's the concept.
So was that a direct payment channel that you set up with y'all, or was that?
So from my phone, I have a direct connection to StarBlocks. And so actually, in order to pay them a penny, what I really did was paid StarBlocks a penny, and StarBlocks paid someone who paid someone who paid someone who probably paid them, and finally made its way to y'all's to pay the penny.
How does y'all's prove to StarBlocks that they're the direct and recipient?
There's more secret hashes that get passed around the network as the way to say, if you can prove you paid y'all's, I will give you another secret key, sorts of fun gyrations. But yeah, that gets into the technical weeds of how the various hops between it each have their own secret key that gets passed around to prove that it actually did get hopped.
So how much did you pay in fees for those two penny transactions?
Let's see here. Because those were each 1/1000th of a Bitcoin. And actually, I actually must have this one reversed. Those had 0 fees.
Okay.
So I must be describing it. I'm directly connected to y'all's and not directed to the StarBlocks. I paid 0.0001 millibits, 0.00000011 fee to get to StarBlocks by routing it through y'all's.
Do you know how much of that went to y'all's and how much went to another node in the past?
Not through the UI on this one. Yep.
But would you be able to tell that from the protocol?
I know that whatever that 11 satoshis went to the first hop, and possibly 9 went to the next one, and then 8.
But you don't know if it was
that.
9 or 7.
The protocol would allow me to tell that. The UI doesn't.
Right. Okay.
Yeah.
That was fine.
So how do you negotiate on-chain or settling fees? Because that's going to be potentially variable.
The settling fee, for actually closing out a channel.
Yeah.
That one would be the if you're on speaking terms with Alice or Bob, or if Alice is on speaking terms with Bob, just one of them has to broadcast their transaction, and then the other one undoes the time lock, so the other one gets it immediately, so it doesn't have to sit in the time lock. Okay. Does that make sense?
So, like the mining fee to close the transaction.
That would be negotiated as part of the state updates. Right now, the UI for most of the wallets doesn't have that. That was one thing I was expecting to see more of. But in opening the channel, so like when I first opened this one, of course it won't show me on this one because I've already opened it. When I joined up to join y'all's as a peer to open a channel with them, I put forth how much I wanted to put into this channel, knowing that I'm going to be paying them, and they put in 0. That was just their automatic, we're not putting in any of it. However, there is a, this guy, this one is a Testnet faucet, but it's a Testnet faucet that goes through the Lightning Network. So it's the idea that you aren't going to be paying them, they're going to be paying you. And so instead of you initiating the connection to them and saying, I'm going to put 20 Satoshis in the channel, this one they have you fill out the amount, and of course it's open, so they're going to always accept it. You have to put in who are you to connect to your node, how much do you want the total amount of the channel, so how much is going to come from you, and how much is coming from their side. So this particular site has the option where you can configure, and they of course set their own permissions of we're agreeing to this sort of a thing, and they're setting limits on how much sanity they're going to put on this form check. For y'all's, they don't have that option. They're saying, we're never going to put in any on our channel currently. That's the way that's configured. And so it's going to be up to the merchants of how they're going to negotiate and give access to through web interfaces to sort of say, wait, I want this one to be balanced. I want us each to put in this sort of amount, and it's going to be a per merchant pay on that one.
So to kind of go back to the receipt, auditing aspect of it, let's say I buy a TV through the Lightning Network, does it require either myself or the merchant to kind of keep that price/record? I guess from an auditing perspective, I wanted to repay on January 1st at 5
for
TV.
Sure. The protocol itself does not dictate that you or if you're making these transactions, the protocol itself does not dictate once it's closed out. You could throw those away if you don't care, about keeping the intermediary steps on there. If Alice wanted to prove someday that yes, she did actually pay specifically for a croissant and not just for a visit, she would have to keep those herself. But the protocol does not force you to keep those.
So I guess from a high level question, why, as a merchant, what is the benefit of this over concurrent banking system with credit cards or anything like that? Why would I choose the Lightning Network?
Sure. The benefit of this for the merchant, there's a couple of pieces. The main thing is the trust piece that you can do the splitting it out. That I think a lot of what is involved currently with the merchant interfaces of paying for a meal at the end of, or paying at the end of a meal at a restaurant, or putting a down payment on a car to prove that you're going to pay for it, is due to the fact that you need to alleviate the trust somehow. And so what this can benefit, or what this can be, with a credit card transaction, you're trusting that MasterCard or Visa will be the intermediary and will pay the IOU at some point. And if they can't get the payment from the credit card holder, that's up to them to figure out. With this one, you're not trusting a company or an intermediary, you're trusting math to do it.
Let me coming from Visa. Here you go. It's 2 to 4%. Because merchants love and hate Visa for that reason.
But someone still needs to close the channel. Right?
Someone needs to close the channel, but the point is here, right now you have an instant transfer of funds. Where even with fast cash enabled accounts, which are hit or miss, you're looking at 24 to 48 hours, and which are subject to pulling those funds back based on rules that are outside your control. Right. So with this, all these rules are defined up front. That was kind of my question with the standard contracts, which you can establish. Everyone knows the rules you're playing with, and the money comes back and forth right there. There's no pullbacks after a period of time where you're subject to someone else potentially being a dick. You can just be
your money is only good as right? It's not, you don't actually have money, so you set it all chain.
Yeah, no, that's true. That's still, but this is still done programmatically and not subject to rules outside your rule.
Yeah, that's the bit of here of while her funds are locked up here, yes, in theory you could say these are locked up. And if this was only between Alice and Bob, it's the Alice can only spend those 3 millibits with Bob. Then it's more like a gift card. She's chosen to lock up however much funds, and she will use it up. The only reason you do that is if you think you're going to use up that amount of a gift card, sort of a thing. But this example is in isolation. The idea is this is a network. And it's the idea of, you could say she doesn't have the funds until she settles off chain, or settles on chain. But the idea of treat this like your hot wallet. It's like your month, if you're using a credit card for monthly transactions and paying it off every month. is kind of how this would work. Of, load it up at the beginning of the month, you have to flip it to the beginning of the month instead of the end of the month. Load it up at the beginning of the month, use it the whole month. If you guessed wrong and you need more funds, yeah, you're going to need to close and reopen it. If you guessed too high and you still have some left over, you could settle it back over or just let it ride to the next month, sort of a thing. And so that's kind of the idea of, it works in isolation if you want to do that and for certain situations, but it also works, so it works like a gift card in isolation. In combination with a network, it's like getting a Visa gift card piece of it that is accepted at many places. You can use that many places.
But outside of the United States, one of the things we have issues with credit with is people feel like it's out of control spending. So doing it in the model that you're talking about, it's spending control, which is a
Like you
benefit
can't go
outside
over.
the United States as a whole. I mean, we may not see it here globally. There's going to be a big appeal for that.
Yep, that's it.
So like my only concern is that say like Lightning Network is successful, it scales to like millions of users, right? So I'm assuming that you have a large number of channels that you open and a large number of hops. The problem with large number of channels is that say you have 10 payment channels that you have to route your payment through, you have to like lock up your funds, like 10% of funds in each payment channel. So the actual recipient who's getting the money will be able to receive only 10% of the initial amount you're locking. So your money can't be in 2 payment channels at once, which means that you're expecting to put down a higher stake in the beginning to estimate how much you actually want to use the network. That's kind of like one point that I had. Another one is like the hops. You're basically loaning out money. So when you're loaning out money, you're taking risk for every one of those funds as well, which makes it harder because with larger hops, say you're like transacting like $1,000 a month and you have like 20 hops, you have like have at least $20,000 in liquidity to be able to transfer those hops because you're supposed to. Yeah, you get it. So my only problem is that the only way this will work is like if you have a large centralized hub, like Coinbase or like Visa or someone actually maintaining, which in my mind then is just recreating these same payment systems that we have today. So I guess like how do you solve the trade-off between like having larger channels and larger hops, and how do you balance that in order to like have an easy way for users to not stake a lot of money in the beginning?
Sure. I'd say the counter to that piece of I don't have enough money to be staking, to open 50 channels is that's fine, you don't need to. In this network, any 2 nodes can pay any 2 other nodes. You can be this node out here, or you can be this node out here, and your functionality is the same. You don't have to have 50 open, you could just have 1. So if you say, I only have enough funds right now to open a $20 channel, okay, you got $20. You can use that $20 at any of these merchants. And you may, by nature, if you're only having 1 connection, be subject to the fees that are on that route. And if you really want to save money, you might want to do research and figure out if there's a better place you can connect. But the main structure of the network is you don't need to be highly connected. If you want to be, you can. And if you want that as a business model, you could. So yeah, it definitely does not require you to lock up funds in many different channels, which again, then is fragmenting it, and then you can only pay certain people certain ways. You could be out here with only 1 or 2 connections, locking it up to whatever your capabilities are. You don't get limited functionality from that. We got a bunch here now.
Yeah. So I'm happy to take this offline, but isn't what Sid just described solved by the hash time lock contract? Isn't that the whole point of having the hash time lock?
I didn't touch on the second part of your question of the loaning your money out piece of it. Yeah, it's even if you're the person on the edge who doesn't trust the person you're at, yes, you're trusting that this person will pay the rest of the network on your behalf, but the actual transactions that are signed as state updates are your proof of that. You don't need to trust the person, it's trustless. You have the transaction that you could take somewhere else, even outside of your Lightning wallet, in theory, if you could export it and broadcast it to the mempool to get out of that situation.
I just wanted to check, because that caught me off guard.
Sure.
Just to further this point, one of the original ideas of Bitcoin was to create a decentralized network, which it looks like by this map, what we're seeing is this Lightning network is creating more of a centralized network. So maybe it's undistributed, decentralized. But is that the next step then beyond Lightning, is to think of how do we get to a distributed, decentralized network?
I think yes, there are concepts of thinking beyond Lightning, that this is again of the whole alphabet soup of features that's being added in here. This is the idea of layer 2 And then, yeah, there may be other layers on top of it to continually optimize this and move it on to a next level if that's indeed needed by the network.
Because, I mean, is there a benefit to going through a connected hop other than you just guaranteeing paid? I mean, is someone who you're sending the payment through taking some risk as well for collecting the fee?
I'd say the main risk is going to be like the solar flare argument of you're trusting the transaction to be saved on a hard drive somewhere.
Because it may be
for
more
those-
tolerable if someone who is in the middle of the payment from putting the point
Yep.
assuming some kind of risk or taking it or providing that.
Yeah. And yeah, so that may be if you're connected way out on someone who's not very well connected, it's guaranteed you're going to have multiple hops. Even if you're not this guy, if you can identify who that is, if you make a direct connection to this one and they're connected to many, then it's now only one hop to most of the network, which is probably kind of the idea here of all these little swarms of guys. You know, they chose this one to connect to as opposed to this one out here because this guy has 10 more inside there. The odds of them having a one hop transaction are much higher, whereas here it's virtually guaranteed it's going to be more than one hop piece of it. And yeah, that sort of arranging of how's the network going to shape itself that way is still to be determined. Yeah.
What does this do to the fungibility of Bitcoin? Most of Bitcoin is locked in.
Well, get that.
Does that affect like?
Sure. The fungibility idea, or we're back to the idea of it's locked into this network. It's locked into this network, sure. If you open a channel, your funds are locked into this. But it's like saying you have a gift card to this network. Sure, you use it in any of these locations. Is that really locked?
So I guess my point is if I run a hub or a node and let's say the US government doesn't like my node or my hub, and your transaction rests with my hub, does that not cause fungibility concerns, I guess?
I guess, yeah, if you have a long-running long-running channel with someone, and this one actually turns out to be a bad actor and the government takes them down. Yeah, your connection linked to it, even if they get taken down, whoever they were connected to still has that transaction. So yes, you're down to only one copy of the transaction instead of two. Hopefully you can get that one broadcast. But even if you're out here and it's this guy who's taken down, it's this guy who's at risk and is going to be incentivized to broadcast it. Your relationship with this guy is still assured, as your only liability is the one hop away ones. And if it is one hop away, you have the transaction. You can broadcast it if you want to.
And maybe I missed something, but I guess I'm curious. Like, so let's say you go through like it's 2 hops. If my Bitcoin goes through that hop, that node that the U.S. government doesn't like, for example, is there any way for someone to find out that my Bitcoin went through that hub?
It's going to be, and so this is going to be the question of how they respond legally. But the idea is, it's not your Bitcoin that goes from here all the way to here. It's your Bitcoins that goes from here to here, and it's this guy's Bitcoins who go from here to here, and it's this guy's Bitcoins who go from here to here. So in terms of is it yours? Is it that Bitcoin? Is it whose was it?
A judge is not going to buy that.
That's not for me. I'll leave that to someone else. But yeah, that idea, because it's the same idea of Alice and Carol just trading IOUs. Of it was Alice who wanted the donut, but it was Carol who paid for it. Sort of a thing. And yeah, so the laws need to be figured out for it. From a technical perspective, the argument is your funds only go back and forth between here. But the reason why you say, I'm going to give you a millibit because you gave me a promise that you're going to give a millibit over here. And so, yeah, the 1 millibit doesn't actually move all the way through. It only goes every one hop. Yeah, over here.
Are all these hops equal? I mean, I know you said that maybe the transaction fee might be different between them. But is there anything else that could slow them down within a network like this?
It's going to be the size of how much was put down as collateral by both sizes as well. And the idea that the parties need to be online. So in the same way that, for an internet network, the devices need to be online. Also, that's kind of if you want to be a centralized hub, part of the service you better be offering is 99.9% uptime piece of it, because if you're offline, no one who has a channel with you can do anything. Piece of it. Yeah, agreed.
When you said that they're public, is that like their pub key at StarBlocks.com? Because I saw there was the IP.
Yes. Right now, the protocol for connecting to a public node is they have a public key, which is an identifier, but then there's also an IP address, which is kind of a cheat to say contact me at this DNS address and you'll be able to find me. The proof is the public key, but the IP is kind of the help to get to so you don't spend time wandering around the entire network trying to find who has this public key piece of it.
So then what makes the blue nodes anonymous? Or?
I believe for this one, excuse me, this is from Async, and I believe they've been adding metadata on top of it as kind of a block explorer piece of it, so they've been personally identifying, we know this IP address is a server that belongs to whoever piece of it. So yeah, so most of the colored ones, I believe, from reading their notes on it, are like representing servers that are like online all the time. Blue ones might be individual users that drop on and off the network piece of it. All right, yeah.
Is it true? I thought the network was going to be onion routed, so you couldn't really see the path. You couldn't recreate the path. You could only see where it came from the prior node. And
Don't think so on that one. I know a couple of the more privacy-focused coins like Monero, which we had the presentation on, we're looking at in terms of how the information was broadcast, routing those. At this point, the bare Lightning protocol, I don't think includes that. Does anyone else?
I think Labs are on your
Okay, so it might be a feature of Lightning Labs' particular client.
Well, your payment links are still obviously known to other nodes.
Mhm.
So I think that if you use like a certain Coinbase, they know your KYC, so they know who you are.
Mm-hmm. All right, yeah.
So the proof that I have my money is that I can cry foul on any fraudulent transactions.
Correct.
Does that mean that users of this network are going to have to cash out if they're going to be offline for longer than their shortest contract?
Of the ones that you yourself have opened?
Of my payment channels.
That's the idea of, or like my example of like if Alice goes into a coma,
Yeah.
that piece of it, then hopefully she's trusting Bob. Yes, if Bob knew that Alice was in a coma, then it was his chance to sneak in and could fraudulently close it, knowing that she's going to be offline for a week, piece of it. So yes, that's one of the weak points of it, but that's also then the opportunity for companies and other services to be on guard to have watchdog services that, hey, if you tell me your transaction IDs of what you're looking for, I'll let you know if these sort of things happen. So those sort of things. So that's a weakness of the protocol itself, but an opportunity for layer 3 stuff to happen on top of it.
So it comes back around kind of like fundamentally to deal with the scaling problem, you need more trust and more centralization.
Mm-hmm. Well then, and this one is the trying to get rid of, you don't need the trust. And if you want to naturally become centralized or become a hub piece of it, you can. And there'll be financial incentives to be a good actor as a central hub. And also disincentives of if you become a bad actor and start charging too much fees or start dropping things that people can route around you. Yeah, right here.
oh, do we have any data on what it looks like on the mainnet right now?
On the mainnet, there's like 5 nodes. Because it is only the people who are wise and brave, wise enough to modify code and brave enough to try it, risking a bug, losing the transaction. Because again, I was using an example like Solarflare losing your transaction. Right now, it's the wallet software itself could, corrupt its own database and lose that transaction. So there is that risk of locking your funds forever. Yeah.
So I guess right now miners are kind of competing with each other for on-chain transactions, right? So eventually miner rewards will go away. So if this is the way that most people are making transactions, and there'll probably be hubs that are making the most money off of transactions being routed a certain way, then does that not open up an opportunity for miners who are still settling on-chain transactions to, I guess, attack this network? And I guess my question is, how can they attack this network?
Attacks for this network, this one is a visualization of the channels. There's also the other layer, which is just the network, the peer-to-peer network. And that network is susceptible to the same sorts of attacks like a Sybil attack, or just DDoSing attack. If a node can't connect to the internet or can't connect reliably to the rest of the network, they're vulnerable the same as they would with any peer-to-peer network. So that's a main attack vector for this sort of a network. The whole rest of it would be if you can position yourself looking like a good node and then suddenly become a bad one, trusting with user education to not make them stop doing that if you're like hiking up the fees and they don't notice sort of a piece. But I guess that's something that hasn't evolved yet because the protocol is only a month old. There hasn't yet been the watchdogs to be able to actually monitor it or even best practices yet, because there's only the practice, not best practices yet for that.
It's kind of an interesting thought that the mempool cools down and there aren't, people aren't trying to get Bitcoin by mining, that, deep in the future, just putting your Bitcoin into a bunch of channels to get more Bitcoin would be eventual possibility.
That ideally, if the
that's
fee pressure goes down, that like right now we've seen the mining difficulty just going up and up and up and up as Bitcoin is still becoming more aware. The community is learning more about it, but still it's not reaching a major threshold. That at some point, in theory, the goal is slow and steady wins the race as we start chipping away at the desire for on-chain transactions. The pressure for on-chain transactions goes down, therefore the fees go down, therefore less miners are actually saying, well, this is not profitable, and the difficulty could go down to compensate. You don't need to have the amount of miners that we have. The fact that we do means the difficulty is up. If miners suddenly decide that's not profitable, I don't want to do that anymore, the difficulty can float back down again. Same for that one. Yeah.
You said that like a lot of this stuff is in alpha. There's 5 nodes on the mainnet. Do you have any sense of how far we are from stable releases and when it will be adopted?
Well, I would say in terms of me setting up for this demo and installing Lightning Lab and Eclair, I filed 6 bugs just to get it set up for today. So not quite close. Alpha definitely, and I would say maybe a month or 2 would be where I'd start to say it. Obviously, there are the cowboys out there who are saying, give it a try, and so it's doable, definitely, and it's growing. But in terms of mainstream, adoption of can I trust my monthly paycheck to it, I'd expect that not to be for like another couple months for that one. But to start experimenting with, hey, maybe I'll try, refilling, a month's worth of phone card bills, a $30 or a $40 or $50 transaction, maybe, in a month, to trust sort of that thing. But a couple $1,000 transaction, like my monthly credit card bill sort of a thing over Lightning is still a little ways away.
It's been in development for years though, hasn't it? I mean,
the protocol has been in development for years. These actual software packages, now that the protocol is solidified enough, the development of those has been more recent for those. Yes.
There could potentially be other issues too with scaling it to retailers because Bitcoin transactions that go through retailers that are subject to security interests could have liens. So like if you give it to Joe's coffee shop and there's a bank that gave a big loan to Joe's coffee shop, that bank could potentially track down whoever they send Bitcoin to and pull it back.
Right. Coloring those zones.
Which is a potential problem that would need to get worked out just with some like revisions to the UCC and so on. But as it is now, that's the worst thing you would do is want to be a pioneer here and then have a credit union come and ask for your Bitcoin. So.
Well, this one, I gave a couple of examples of if Alice wanted the record of what she actually paid for, but we have the other side of it is the know your consumer laws, and if those evolve, Bob may be legally obligated to keep those transactions such that he can verify to the government that yes, he actually did do these sales, he paid the sale, the sales tax was appropriate on those sorts of things and whatnot. So there's incentives on both sides possibly for keeping that state around.
And there's probably still a receipt generated by Bob there, right?
Mm-hmm.
Is there something that I could pull down, maybe throw up on my personal machine or AWS to act as a node? Maybe I wanted to make StarBlocks 2, but only just give it out to my friends.
Sure. And there's starting to be, right now, as it's testnet capable, the few, I believe it's Lit and C Lightning and LND are all command line ones, which are intended to be run on a server, connected to via RPC, just like a Bitcoin daemon running, which is, I believe, how the YALs and StarBlocks ones are operating right now, off of those. Obviously, the StarBlocks is made by the company who's also making the wallet. I believe YALs is just an independent developer, is not part of this development team, and is just using the service that's there, I believe. Yes, it.
Is there a case where a payment doesn't settle at all? So say Alice wants to pay Starbucks, and there's multiple hops that she has to go through, but the final payment channel doesn't exist, but the last person doesn't actually want to go to Starbucks. Is there a case where the payment doesn't even settle and just disappears and Alice just
Yep. And I actually had that happen with trying to do some of these test ones. I gave the experiment where I didn't have the connection directly opened, and when I had the QR code up of StarBlocks is waiting for my payment. If I intentionally broke my connections to it, The Claire wallets basically gives effectively a 404 if I can't find a route to that thing and it stayed up there waiting for connection. So yes, with the same sort of network connectivity issues that would exist in sort of an internet network, you can still end up with a 404, I can't find this thing in the network. All right, yeah.
I'll ask a related question, but does this mean that Bitcoin is now a peer-to-peer electronic cash system anymore? This is the main scaling system. Doesn't this mean we're just going to become a mesh of settlement, payment settlements?
The few things you said there of, yeah, the peer-to-peer cash piece of it has become a rallying cry for some of the philosophical differences between the groups. But also as I mentioned at the beginning, this is not meant to be the silver bullet. It's not the only thing that's going to happen. Yes, with the addition of this, there's another mesh network on top of it. But that doesn't mean that that's the final destination or the only thing that's happening or the only scaling solution. If Lightning Network fails and no one likes it, or there's a big security hole that's discovered with it, there's other things that are in the works. Piece of the idea. If Lightning Network fails, it's not the end of Bitcoin, it's the end of that idea. We move on to another one for that piece. Is in terms of that philosophy of how they're approaching this piece.
But I mean, aside from Lightning Network, is there any, I mean, this has been in work for multiple years, right? I mean, I don't say, yeah, aside from second.
Well, all these other ones down here along the bottom are also in the works. And so, yeah, there are various stages of completeness. Lightning Network is the one that's most eminently ready to be used, which is why we're talking about it. The other ones are in progress, and I think over the next couple of months, I believe these two on the left here, Mast and Schnorr, have been giving signs that they're nearly ready as well, so we'll probably be hearing more about these guys next. Yeah?
Do you know what percentage of transaction on Bitcoin today have SegWit in it?
They were
10%?
It was between like 8 and 10%. When last I saw a couple of days ago, I believe.
I mean, in my mind, I think the biggest thing that the network invented is implementing SegWit. Like when the mempools are all filled up, it's because of the Coinbase. You know, you can correlate the amount of traffic that they're having. That's the amount of mempool transactions. So it just seems like if we implement SegWit itself, it's like solves a lot of problems that we have today.
It does solve some, and I didn't touch much on it since we were focusing on Lightning Network today. But both of these two things require user change. That's part of the thing of SegWit has been available as a feature since, what was it, late August. But it requires user action to actually start using it. It requires developer action to make the wallets actually do it. And then it requires user action to actually move your funds from an old address into a new address. It's a relatively simple action. It's just simply send the funds to yourself. Your wallet will create a new address that's this new SegWit capable address. That's all you need to do. I'm not going to give a whole lecture on it. It's fairly easy to do. But the idea is it first needs the developers of the wallets to implement it, and we've kind of stagnated on that one. Part of the one fork that didn't happen, the SegWit 2x fork, did in some levels distract a bunch of developers who were coding against, guarding against that fork happening or how they're going to manage that. And so some are now getting back to the implementing SegWit as a feature, but that's been a lot of the network or the community push of get the developers to implement that such that the users can start switching over. The users can't start switching over until the developers of individual wallets. But in theory, that would be a simple switch from a user experience to do much less of a user experience switch. Lightning Network is going to be a big user experience switch. Like I mentioned, like for the car example of learning to merge on an expressway as opposed to just driving down a country lane.
Not exactly a lightning question, but could you explain in any easy terms what an atomic swap would be?
Well, in a nuclear reactor, there's no.
The idea of scalability is other SegWit coins being able to.
We can talk more about that offline. The key piece of it in atomic swap, briefly, is the idea of being able to prove across blockchains that something happened, such that instead of trusting a online exchange, that when I say I want to trade Ether for Bitcoin, that I'm not trusting the exchange to do it, that it's actually in the same way that the Lightning networks are, you're trusting the math, that you can actually trust the math that the other person deposited something on a completely separate blockchain, and I am depositing something on my blockchain, and that we're going to trade for those. All right. Any other questions? One more?
So other coins like Bitcoin, Ether, and stuff are also building support for Lightning Network, right? how do they talk to each other? Or could you like theoretically rule like a DEX or the decentralized exchange on the Lightning Network?
And that's kind of the idea of getting to the atomic swap idea of, yes, Lightning is a protocol. If the Bitcoin network is talking the Lightning protocol and something else, Dogecoin, Litecoin is talking Lightning, then in theory the two Lightning things can be talking to each other at the level 2, and can they be actually talking to things on the bottom level? And that is kind of getting into the idea of atomic swaps. Of can they prove something on layer 2 that happened on layer 1 on different places? And they're working on that. Atomic swaps are one of those pieces into that, I believe. To the best of my knowledge, I haven't done much research into that one yet. All right. Well, thank you guys for coming on this one.